Stats fans, fine Friday morning, a little snow out there right now. Hopefully it won't be too much. Friday, this is the last set of material for Chapter 6. We're going to be dealing with confidence interval with the standard deviation and variance today. Hope everything, once again, is going well for you and your family at home. You're staying away from the illness, keeping your social distancing out there. Hopefully things are going well. I miss you guys. You wish you were here in class, but it's our reality. So today we're going to talk about population standard deviation and having a confidence interval for a population standard deviation. We've talked about the mean. We've talked about a percent. Now we're going to talk about standard deviation. Once again, this is the last of the material that we will go through. Monday we'll have an in-class assignment and also a worksheet that sort of pulls everything together. Tuesday will be a review day. Wednesday we will look to do a quiz over Chapter 6 here. Thursday will be a review day over 5 and 6. And Friday next week we will have a unit test over Chapters 5 and Chapter 6, dealing with what we did with the Z-scores in Chapter 5 and also what we're doing with the confidence interval in Chapter 6, and that will be next Friday. So we're quickly coming to a close of the school year. Please do keep up with the material that we're going through here so you're not overloaded. Keep up with the material, get yourself into a routine. Today, once again, we're going to look at a confidence interval for the population standard deviation and also the variance. You will need, I gave you a printed, or I sent you a T-table that we've used the last couple days. On the back of that, the second page of that is called a chi-squared table. We'll be using that today. When we have an x that is squared, and more or less a chi is sort of a rounded x. I couldn't get a rounded x. This is a symbol for chi-squared. It's a sort of rounded x that you have there. That's a chi. That's once again a Greek symbol that we will utilize. Chi-squared distribution table will allow us to do calculations for confidence interval for the variance, and that will give us standard deviation. So we'll be dealing with the population variance and the population standard deviation. And once again, we're just dealing with a confidence interval here. And if I'm going too fast, once again, just hit your pause button and get yourself back up. I promise I won't continue to talk as we go through this. Okay, we still deal with our degree of freedom. Okay, and -1, we'll still be dealing with that. We have a C value here. A C value is a decimal equivalent to the level of confidence. The decimal equivalent to the level of confidence. So if we're dealing with a 90% confidence interval, that means our C value will be 0.90. Okay, so we just take our confidence interval and change it into a decimal. We have alpha values that we'll be utilizing. Okay, I really don't need that there, the square values there. The alpha values are calculated we have two different values. We have 1 minus c divided by 2 and 1 plus c divided by 2. These are your two alpha values, 1 minus c and 1 plus c divided by 2. And if we take a look at your chi-squared table, we will be utilizing these alpha values along the top here. It's sort of like your confidence interval that we use in the T-table, but we're using these alpha values here to give us values from the table value. So we have an alpha value left, alpha value right, 1 minus c and 1 plus c, we divide them by 2. Using this, and the degree of freedoms, okay, we find values from the chi-squared table. These are chi-squared values, and then we can calculate confidence intervals for our variance. Once again, this is our population variance here, and how we calculate this. We have our degree of freedom, This here is the S squared. Remember, is your sample standard or sample variance. This S squared value is your sample variance. And on the bottom here, these are just table values. We are getting table values for our bottom values here. Now what I tend to do is I have, this is alpha right, alpha left. I don't really get into the rights and lefts too much. I just use my mathematical knowledge in my brain. This has to be a smaller number than this. This is smaller than this. So if I'm dividing by these table values, that means this is going to be, this one's going to be bigger. This value is going to be bigger because if I divide by a bigger number, my division will come up with a smaller value. If I had 10 divided by 2, I get 5. If I have 10 divided by 5, I get 2, a smaller number. This here is going to be smaller. So I take a look basically at my two table values and which one's bigger and which one's smaller. I put the bigger one first and the smaller one second. Now, dealing with the population standard deviation, we square root everything. Whoopsie. We square root everything, and we get a confidence interval for our population standard deviation. And typically the standard deviation is one that is more used throughout statistical analysis. We don't use the variance as much, so we will utilize this a little bit more. And what I want you to do with the final statement is make your final statement just for your standard deviation. We are 90% confident the standard deviation for whatever is between this value and this value. It's very similar to what we've done with the other things. It's just a different type of formula that we have here. A different formula. Let's take a look at a problem. I randomly selected and weighed 25 samples of allergy medicine. The sample standard deviation is 1.2 milligrams. Construct a 90% confidence interval for the population variance and standard deviation. Okay, now you have to really watch in regards to when you put these values down. We have n is 25, which is fine, but here we are given that the sample standard deviation is 1.20. So this is only our S value. This is not S squared, this is our S value. Now if I said the population variance was 1.2, then it would be S squared. So you have to watch. We have a confidence interval of 90%, which tells me our C value is 0.90, the decimal equivalent to the confidence interval. We have two alpha values to calculate. We have 1 minus C divided by 2 and 1 plus C divided by 2. So we have two alpha values that we're going to be dealing with. So we take 1 minus C and 1 plus C divided by 2. So I have 0.1 divided by 2, which is 0.05. And then we have 1.9 divided by 2, which is going to give us 0.95. So these are our two alpha values. My sample size is 25, which means my degree of freedom is 1 minus that, which is 24. So now we go to our table. And we look at table values. So we go along the top. We have 0.05, so we go over to 0.05. Make sure you get 0.05 and not 0.005. So we go 0.05 and take that all the way down to a degree of freedom of 24. And we get 36.415. And then we take our 0.95 and take that down to 24, and we get 13.848. So those are our two table values. Now to calculate our confidence interval for our population variance, we have n minus 1 s squared divided by alpha, I'm sorry, my chi-squared value, and then n minus 1 s squared divided by chi-squared, once again, value. These, once again, are the table values. These come from the table. And this value here has to be the bigger of the two values. So I'm going to use 36.1415. So we have n minus 1, which is 24, times 1.2 squared, divided by 36.415. And then we have the exact same 24 times 1.2 squared divided by 13.848. Once again, this value has to be smaller because I need this to be the bigger value. Now, what I usually suggest to students is work yourself down, where I'm going to do this calculation. We have 24 times 1.2 squared divided by 36.415. Let's try that again. 24 times 0.12 squared divided by 36.415. It might help if my gloves would not get in the way. 24 times 1.2 squared divided by 36.415. There we go. That's a little bit better. We have 0.949. And usually what I will do is I will just take that and square root it so I can deal with my standard deviation. So I'm going to take the square root of my answer, 0.974. And then I work with the other one over here where we have 24 times 1.2 squared divided by 13.848. 2.50. And then I could take the square root of my answer, 1.58. So from this we can write our, once again, I utilize this for our statement, the standard deviation. We are 90% confident the standard deviation for the allergy medicine is between 0.974 and 1.58. Once again, you need to get that final statement in there. As part of spring break planning, you randomly select 10 hotels in Cancun, Mexico. Wouldn't that be nice right now? and record the room rates and calculate the sample standard deviation to be 34.4. Why you would worry about the standard deviation, I don't know, but it was a problem that was given to me. Use an 80% confidence level of confidence to calculate the confidence interval for the population variance and standard deviation. So once again, I'm going to want you to work this problem by yourself. So as we've done in the past, just wait till I finish my instructions. I'm going to ask you to turn the video off, work the problem, then turn the video back on and check your answers. So at this time, just follow along with what we just did up top. Follow along with what we did. Work through the problem, shut the video off, work through the problem, turn the video back on, check your answers. We have a sample size of 10, degree of freedom turns into 9. We have a sample standard deviation, once again, is 34.4, so we have S is 34.4. We have a confidence interval of 80%, which means our C value is 0.8. So we look at our alpha values. We have 1 minus 0.8 divided by 2, and 1 plus 0.8 divided by 2. So 1 minus 0.8 is 0.2 divided by 2, so we have 0.10. And 1 plus 0.8 is 1.8 divided by 2. This gives me 0.90. So using our degree of freedom and our alpha value, we go to our table. So alpha value of 0.10, make sure you get 0.10, degree of freedom of 9, we get 14.684. So our table value, our chi-squared value is, what I said was, let's see, 14.684. And our chi-squared value here, 0.90, go down to 9, 4.168. So our population variance will be in between. We take a look at a degree of freedom, which is 9. Our variance, 34.4 squared, divided by our bigger, smaller, or table value, 14.684. Then we have 9, let's see, 34.4 squared divided by 4.168. So clickety-clacking through the calculator. 9 times 34.4 squared divided by 14.684. We get 725.3. And let's see, let's do that, 4.168. We get 2555.2. And we could take the square root of my answers, so we have 50.55 here and 26.93. And then once again, finish off with your statement. We are 80% confident the population standard deviation for room rates in Cancun is between 26.93 and 50.55. There's a confidence interval for standard deviation and variance. We use our chi-squared table. I posted some worksheet problems that deals with the confidence interval. Once again, next week where this will go to is next week. We will look at an in-class assignment on Monday with a worksheet. On Tuesday, we'll have a review day. Wednesday, we will have a quiz over this chapter then, chapter 6 in regards to confidence interval. If you have any questions, feel free to email me. I'll answer the questions as quickly as possible. Once again, please do keep up with the material. Other than that, I'm out. It's Friday afternoon or Friday morning. Have a good weekend, everybody. Stay safe, stay out of trouble. Hopefully, we'll start getting back to some normalcy. Adios. Miss you guys. Bye.